Hello everyone. So today we're going to be working on solving quadratics. And in this video, we're going to be solving quadratics by completing the square, okay? By completing the square. You will know what exactly that means by the end of this video, so hold tight. We just have to go through a few key things in order to make sure that you can do this effectively, okay? So this is yet another method. We have several methods to solving quadratics. We have factoring as a way of solving. We have taking the square root as a way of solving. You can solve it graphically if you know how to do that, right? Looking at that x-intercept. And you can solve it by using the quadratic formula, right? So there's definitely a few ways to solve, but this is one of the newer ways that we're introducing, so get ready, okay? The first thing you need to know is the standard formula of a quadratic, okay? The standard formula that is written in. So I'm going to show you what that is. The standard formula of a quadratic is written as ax squared plus bx plus c. Standard formula, right? Okay, the standard form is actually written in a trinomial, all right? You'll notice that with one squared term, okay? And it's always going to be a, b, and c, right? And so when you see a quadratic expression written as something like this, then you can quickly identify what the a, b, and the c is, okay? So our a, let's write it on the side, a, b, c, right? Our a would be 1. There's always an imaginary 1 over there. Next to x, when nothing is there, our b would be 4, and our c would be 12 here, okay? Let's do another one. Alrighty, I'm going to leave our formula, and I'm going to write a quadratic equation. Let's try another one. What is our A, what is our B, and what is our C? If you need a little help from last time, I'm going to draw some arrows for you, right? So this is our A, this is our B, and this is our C, right? So we know that automatically when working with anything, if there's nothing next to x, there's automatically an imaginary 1 there. So just as a heads up, to remember that. So our A is 1, our B is 3, and our C is 4. Okay, let's do another one without the formula. Without the formula. Okay, and what is our A, B, and C here? You can pause the video and give it a shot, but I'm going to get going. Our A is 4, our B is -3, and our C is 9. Okay? Very, very simple. Very, very simple. But you need to remember this. A, B, C. Need to remember that. Alrighty? So we're going to move forward. If you do not understand the standard formula of a quadratic, you're going to have a hard time when I'm saying forget the C value, the B value, or what is our A value. And in particular, you're really going to need this because the quadratic formula, which are probably one of my next videos, really talks about that A, B, and C. So definitely get used to understanding what that is. All right, so solving quadratics by completing the square. Well, now we understand what our A, B, and C is. We're going to use that to help us. So completing the square is yet another method, and is primarily used when you can't factor. I would use factoring as a way to solve quadratics first. It's probably one of the quickest and easiest ways. So let's take a look at this quadratic equation here, and I'm going to show you why factoring could not be used here. You may want to go on to completing the square or using another method that you already know, okay? So Especially it depends on how well you are with your factoring, right? So if you can look at this and say, well, trinomial factoring is not going to work. This is not a perfect square trinomial, right? So therefore, you may not use factoring here. All depends. There may be a GCF by grouping. You can create that fourth term. Some people know how to do that. Just depends on your comfortability. But if you're looking at this and saying this cannot be factored, then completing the square will be really helpful to you. You can also use completing the square on any quadratic equation, all depends on your comfortability. Again, some of you may not want to use it. You may start to end up with fractions and saying, you know what, this is just too much. You may want to use the quadratic formula. It all depends on what you're dealing with and your comfortability. But you're gonna have to get used to knowing all these methods, and yes, getting used to a little bit of fractions as well. My examples are not gonna have those right now. I just want to make this fair and simple for you all. So let's dig right into it. This can't be factored. So if this can't be factored using trinomial factoring, then I'm going to try using completing the square to solve this. But I'm not going to solve this just yet. I'm going to show you how to create a perfect square trinomial, because completing the square is actually completing a perfect square trinomial. So you have to know how to create a perfect square trinomial first, which means I'm going to turn this into a perfect square trinomial and then solve it, but that's going to come later. So let's figure out how to create a perfect square trinomial before we can actually solve that. So let's say I have the expression x squared plus 6x. So right now we have our a, we have our b, right? But what we need to do is we need to find our c. And our c in particular is going to be a perfect square trinomial, because that's what completing the square is. It's all about creating perfect square trinomials, completing perfect square trinomials. We don't have that right now. We have this missing value for our standard form of a quadratic, right? So what is that value going to be? Well, all you need to know is a very simple formula, which is b over 2, right, squared. Remember this, and you will be able to create a perfect square trinomial out of thin air. Okay, so what is our b value? That's the question here. Well, since our b value is 6, we're going to take that 6 divided by 2 and then square it. Okay, well, 6 divided by 2, we know that that is 3. Well, 6 divided by 2 is 3. And then we're going to square that 3, right? That's actually 9. And look at that. Our c is 9, and yes, that is a perfect square trinomial. And if you wanted to test the perfect square trinomial, then you can go ahead and perform the test to test it out yourself. What I'm going to do is just give us another example so we can get more familiar. All right? Let's get rid of this as well. So let's see. Add x squared plus 8x. Let's try that. And let's see if we can create a perfect square trinomial here. So remember, we're just looking at our formula to get our third term, or our c. Okay, our 8 is going to replace our b, right? Oh. So 8 divided by 2, or b divided by 2, right? 8 divided by 2 is 4. 4 squared is 16. So it becomes this, which is equal to 16. So therefore, that's our c term. Now, some of you are like, how do we know this? It looks like a perfect square trinomial, but how do we really know that? And you have to remember the perfect square trinomial test in order to really see if it is or if it is not. And that is simply to take the square root of the first and the third term. I'm just going to test it for you so you all can see. Square root of x squared is x. Square root of 16 is 4, right? And multiply them together. And then take that, whatever you get, and multiply that by 2. So we get 4x here. And then we're going to take that and multiply by 2. And that's going to give us 8x, which is our middle term. We know this has passed the perfect square trinomial test, okay? But you have to get comfortable creating this perfect square trinomial, because that's what completing the square is all about. So I'm going to give you another example, and then we are going to move on, right? Let's actually try here. 4x squared minus 6x. No, we just did, maybe we did a 6 already. Let's go with 10. Okay, that'll help us for later. Okay, so how do we create our perfect square trinomial here, right? Complete the square. Well, we take our b, divide it by 2, then we square it. Very simple. So our b is 10. So we do 10 divided by 2. Then we square that. 10 divided by 2 is 5, so that's 5 squared, right? Oh, actually, let me not forget my negative. It's actually negative 10 divided by 2, so it's negative 5, right? Negative 5 squared. Well, that's the same thing as 25 anyway, so that's what we're going to end up with. Plus 25. I feel like I didn't put the plus sign there before. So it's a positive 25. Make sure you have that. Okay, so it's a positive 25 just in case. And you have created your C. So we know our A is 4, B is negative 10, and C is 25. It's a positive 25. Alrighty, so that is our third term. And you have completed the square. Okay, you have completed the square, right? So that is the first step to fully understanding how to complete the square when you're solving for a quadratic, right? So let's get into that a little bit. So it's a few more steps that are going to be added, but it's not going to be difficult at all. We're going to keep our formula because you're going to need to remember that. And let's get going. So you remember that equation that I gave you in the beginning? I said, well, let's look at this equation and let's see why completing the square is important. Well, remember, we can't factor this using trinomial factoring. In your factoring methods, you may not be able to do that with this. So you may be like, you know what other methods do I have? Maybe you can plug this into the quadratic formula. Okay, maybe say, you know what, I'm going to use completing the square. And if you are going to use completing the square, then you have to understand that in order to complete the square, you have to create a perfect square trinomial. And we do not have a perfect square trinomial here because 18 is not a perfect square. So we have to create that. First thing is we're going to move this 18 out of the way. It is taking up space, okay? It is not a perfect square, so we got to get rid of it. We're going to be left with x squared minus, oops, wow, look at that. Forgot my 10x. Minus 10x, okay, is equal to 18. So I'm just going to leave a little space here because we want to create that perfect square trinomial. Remember how we was doing it before? And I'm just going to write that 18 plus 18, right? Okay, so I just want to make sure that we create this third term. Well, how do we do that? We take b divided by 2, and then we square it. Negative 10 divided by 2 squared is just negative 5 squared, which is 25, right? So we're going to put plus 25 right in there. Alrighty, you would think that we're done, except that when you're dealing with an equation, not just an expression, when you're dealing with an equation, what you do on one side, you have to do to the other side. So you just added 25 basically to the left side. So basically, you know that you have to also add 25 where? To the right side. So let's just plus 25 here. Some of you might have wrote it here. That also works. Either way, you added 25. So I just want to make sure you know what's going on here. Okay. And actually, let's do it in the way that you might normally see it in class or some other places. So we're left with x squared minus 10x plus 25 is equal to 18 plus 25. Okay, so 8 plus 5, that's a 3. Add a 1, right? We're left with 43. Okay, and now we can begin solving. So for those of you who are who understand how to factor a perfect square trinomial, now you can begin to break this down a little bit further. So the factoring comes back in, but you have to create a perfect square trinomial, you have to complete the square by getting rid of the original c, moving that, and then replacing it with the c that is a perfect square. So you've completed the square, okay? You've completed the perfect square trinomial, and then now you can begin to really do your work. So what I'm going to do is I am going to move this up. I'm going to get rid of this here, right? We've already worked with this. This has been transformed completely to what we have down here, and which is x squared minus 10x plus 25 equals 43. I'm going to get rid of this here, all right? Now that you've created this, that's great, all right? But you're not done, okay? You are not done. So the first thing we have to do is we have to factor this. Both equal to 43, all right? No problem, okay? What is our A, B, and C here, actually? Let's just list that 1, negative 10, and 25, okay? That's our new A, B, and C. Now, it being equal to 43 is okay. It started off equal to 0. It's been manipulated, so that's fine. You can leave it equal to 43, okay? And then we are going to factor this. So you take the square root of the first term. If you've forgotten how to factor a perfect square trinomial, take the square root of the first term. You take the sine of the second term of the b. What is the sine of b? It's a minus. You can place that in both parentheses. And then you take the square root of the third term and then place it inside. So 25, the square root of 25 is 5. So I'm going to place it in both terms, right? And I know a lot of you might be tempted to do this. Do not do this. That'll give you the wrong answer. Some of you might be tempted to do that. Do not do that, okay? What you're going to do now is you are going to rewrite it as a binomial squared. Okay? And what this does is this allows us to do something that we've been doing for quite some time now, which is to solve for x by taking the square root. So it all comes back around full circle. Right? So this, we get rid of that, right? And now we're left with x minus 5 is equal to the positive or negative square root of 43. And what do we do here? Okay, well, we need x alone, so we need to add 5 to both sides. And then we're left with x is equal to 5 plus or minus the square root of 43. We can just leave it as that. And so some of you might be saying, okay, well, what are my two x values? That means it can also be written as x is equal to 5 plus the square root of 43, and x is equal to 5 minus the square root of 43, okay? And that'll probably leave us with some decimal, and x is going to be equal to some decimal here, okay? So this is how we complete the square. I know you all are like, what? This is nonsense. Yes, but this is a surefire way to solve for x. And do not be afraid here, okay? It all depends on what your factoring is like, how strong you are if you want to use factoring or if you want to try something else. Maybe the quadratic formula, maybe you like that better, okay? But it all depends. So let's take another problem. I'm going to do one more, all right? And I'm going to show you how factoring works. How normal factoring will work and how completing the square will work. So here we have, right, we have a trinomial, right? You may be able to factor this, right? Can you factor this? I'm going to see if factoring works here. Yeah, well, let's see. Let's create our parentheses. Put our x inside. What are the factors of 12? That'll add to 4. 4 and 3 doesn't work. 6 and 2 will work somehow. We got a -6 and a +2. That'll definitely work. Alrighty. So we just do x minus 6 is equal to 0, right? This is what happens when you factor. X plus 2 is equal to 0, right? This is just the factoring method here. Then that's going to leave us with +6, +6. We're going to do -2. We're going to do the inverses, right? X is equal to 6. X is equal to -2. And this is our x's. We've solved, right? Now let's use completing the square to see if we would get the same exact thing. And let's see how long it would take us in order to find our x-intercepts or our solutions, our roots, right? Our zeros. Let's see how long that would take us. So we just figured out that, we just found out that x was equal to 6 and x is equal to -2, I believe, right? We just found that out. Let's use completing the square to see if that's true. Alrighty, so do we have a perfect square trinomial here? No, we do not have a perfect square trinomial, so we need to create one. All right, how do we do that? We got to get rid of this 12. It's an imposter. It's not a perfect square trinomial. We don't like that. X squared minus 4x, right? And I'm always going to leave that little space there because that's going to be my C. That's going to be my perfect square trinomial. And I'm just going to move my 12 over. I added it to the 0, okay? So now we're manipulating here. We're going to take b and divide it by 2, then square it. Alrighty, so -4 divided by 2 squared is equal to -2 squared, which is equal to 4. Okay, so now that we got our C, which is 4, right? It's a +4. We now have a perfect square trinomial, right? Our A is 1, our B is -4, and our C is +4, right? So we used our formula to create a perfect square trinomial, but guess what? What you do on one side of the equation, don't forget to do to the other side of the equation. I almost forgot. So I just added 4 to one side. I'm going to add 4 to the other side. So now that's going to leave me with x squared minus 4x plus 4 is equal to 16. Now we're going to factor this, right, using perfect square trinomial factoring, right? So therefore, we are going to create our parentheses and set it equal to 16. Alrighty, so I think this is already longer than the normal factoring method, right? So you're gonna see why sometimes you want to do something else, but it all depends on your comfortability. Okay, so what happens here is our x goes inside. We take the sign of the middle term. When we have a perfect square trinomial, we can always do this. Take the sign of the second term, and then take the square root of the third term. Right? And if you FOIL that, you'll see that it gets you back to where you need to be. So, what is next? We are going to rewrite this as a binomial squared. So, x minus 2 squared is equal to 16. And then we're just going to take the square root of both sides, right? So let's do that. If I take the square root of both sides, and I'm trying not to jumble this up here, what is that going to leave me with? Well, that's going to leave me with x minus 2 is equal to positive or -4. Right, we're going to break that down even further, and that's going to be x minus 2 is equal to +4. Then we can do x minus 2 is equal to -4. I'm just going to delete this formula so we're not confused. And let's see if this gets us to what we started with when I did the factoring method to solve. So plus 2, x is equal to 6. That's a match. And then plus 2, x is equal to negative 4 plus 2. That's negative 2. And here we are. We have the same solutions. So what that means is you can use both methods here, right? And even if you, you can use all types of methods here, right? But the thing for you to know is that which one you're more comfortable with, which one you're being asked to use, possibly, which one will get you to what you need faster, right? It all depends on you, right? So just get very, very comfortable with completing the square. That means creating a perfect square trinomial, completing the perfect square trinomial, knowing what your A, your B, and your C is. For this one, you're going to have to know how to take the square root. You're going to have to know how to factor, okay? Use your inverses as well, right, in order to move variables and constants over to one side, how to move numbers around, get x by itself. But this is a surefire way. You can actually use completing the square on any quadratic equation, okay, where your factoring may be weak. You might want to go when your factoring gets weak. You might want to go with completing the square. If that doesn't work, you're possibly going to try another method, but get very comfortable with solving quadratics using different methods, and depends on what's asked of you, you may have to produce this. So with that being said, I'm going to head out, watch another video, watch our next video, replay this video, do what you need to do, but understand how to complete the square and complete a perfect square trinomial to then give you the x-intercepts or the solutions or the zeros or the roots, okay, to a quadratic. Okay, and we're done here. Peace.